Let's take a look at applying the quotient rule to this function. Notice that for this particular function, our numerator does contain a product. So when we look at a function and determine what rules for differentiation we need to use, when I look at this, I notice that I have something that looks like a fraction. So I will be using the quotient rule. And now, because I notice that I have a product in my numerator, when I find the derivative of my numerator, then I will be using the product rule there. So let's go ahead and see how this works. So f prime of x is going to be the derivative of our numerator, so d dx of e to the x times x squared minus 1 times our denominator, x squared plus 1. Now, caution, with the quotient rule, this is subtraction, and often students mistakenly use addition, and that is not the case. So be careful. It is subtraction. Then the derivative of our denominator, which is x squared plus 1, times our numerator, which is e to the x, times x squared minus 1. That whole expression in the numerator over x squared plus 1, the quantity squared. So we square the denominator we start with. Now, as we proceed with our derivative here, we will need to be using the product rule as we move across our numerator. So we have the derivative of e to the x times x squared minus 1. And so as we take that derivative, we'll be using the product rule to help us do that. So let's go ahead and see what that looks like. So the derivative of e to the x times x squared minus 1. So derivative of e to the x is e to the x, so derivative of the first function times the second function. Now we are using the product rule, and in the product rule it is addition. Now we take the derivative of the second function, x squared minus 1, its derivative is 2x, and we multiply that by the first function, which was our e to the x. Now, that takes care of the derivative of e to the x times x squared minus 1. Now, at this point, we're ready to multiply by the x squared plus 1. Minus, now we want to take the derivative of x squared plus 1. Well, that derivative is basically 2x plus 0. The derivative of x squared being 2x, and the derivative of 1 being 0, times e to the x times x squared minus 1. And this whole numerator is over x squared plus 1 squared. Now, that's a perfectly good first derivative. However, sometimes we need to be able to analyze the first derivative. So we'll go ahead and simplify this up a little bit. So first of all, notice that we have a common factor of e to the x. Okay, so we're going to factor out e to the x. So to kind of help you see that, this e to the x and this e to the x are going to come out in front of the quantity x squared minus 1 plus 2x. So we're going to have e to the x times x squared minus 1 plus 2x, and then we have the x squared plus 1. And then we're going to have minus, and this e to the x, we're going to just write it this way for a moment, 2x times x squared minus 1 all over x squared plus 1 squared. And now finishing this factoring out of the e to the x, kind of finishing that out before we simplify other components, we have e to the x times, we'll have our x squared, I'm going to write it as plus 2x minus 1 times x squared plus 1 minus 2x times x squared minus 1 all over x squared plus 1 squared. So factoring out these two factors of e to the x, leaving us with this polynomial times x squared plus 1 minus the 2x times the x squared minus 1. Okay, so let's go ahead and simplify that numerator a little bit more. So we have e to the x times, and now we'll be using distributive property. So we'll have x squared times x squared times 1. So that gives us x to the 4th plus x squared. Doing likewise with the positive 2x, we'll end up with plus 2x cubed plus 2x. And then doing likewise with the negative 1, the minus 1, we'll end up with minus x squared minus 1. That takes care of that first component, that first product. And then now minus 2x times x squared. That's going to give us a negative or a minus 2x cubed. And then a minus 2x times negative 1. That'll give us a positive 2x. And then this whole thing, that whole numerator is over x squared plus 1 squared. Now at this point, we start looking for ways to simplify that polynomial in the brackets. And I do notice that I have a positive x squared and a minus x squared. So those will sum to 0. And we do have a plus 2x cubed and a minus 2x cubed. So those will sum to 0. And so it appears that what we're left with is that f prime of x is equal to e to the x times x to the 4th. Now notice we have no x cubed terms, they've added to 0. We have no x squared terms, they've added to 0. We do have a plus 2x and a plus 2x, so we'll have a plus 4x term. And then the only other term remaining is this minus 1, so minus 1 all over x squared plus 1 squared. I hope you find this helpful.